Welcome back to AI.Code.Cast. We break down daily coding challenges to help you rock those technical interviews. Today, we're diving into maximum matrix sum. It's a problem that, it blends matrix manipulation and strategic thinking.
Yeah, it's really fascinating. This challenge pops up a lot in interviews because it really tests how you think.
Yeah.
Like, can you see beyond the obvious solution and optimize, especially when you have constraints?
So let's set this up for everyone listening. Imagine you get a square matrix, just like a grid, and it's filled with positive and negative integers, both.
The goal, though, there's catch. You have to maximize the total sum of all the numbers in that matrix.
Okay, so we want the biggest possible sum from all those numbers.
Yeah.
Got it. But you said there was a catch.
Right. You can't just go changing any number you want. You can only change the signs plus or minus for two numbers at a time. And those two numbers, they got to be next to each other, sharing a side in the grid. It's like, I don't know, they're doing a little dance, flipping signs in the matrix.
So we need a strategy here. We can't just add up the numbers as they are. We've got to figure out, the best signs to flip to get to that maximum sum.
Exactly. Now think about it. If you saw this problem for the first time, what would your gut instinct be? Like, how would you try to solve it?
Well, I think my first thought would be, I'd just try everything. Every single combination of sign flips, and then just see which one gives me the highest sum in the end. Brute force, I think they call it, right? But something tells me that's not the best way, maybe not very elegant.
Yeah, you're right on the money. Brute force, it works, but it can get out of control fast. Especially if you have a big matrix, it becomes a computational nightmare. Like tons of combinations, it just explodes.
Okay, brute force is out then. So what's a smarter way to do this? Any hints?
Well, let's think about the goal again. Biggest sum possible. So what kind of numbers do we want a lot of if we're trying to make that sum huge and positive?
Positives. The more positive numbers we have, the bigger our sum's going to be. Like ideally, if we could just make everything in the matrix positive.
Exactly. Now, obviously, we can't just wave a magic wand and flip every negative to positive. But this idea, it leads us to a useful concept. Have you thought about absolute values?
Absolute values, okay.
What if we start by pretending everything's positive already? Like, calculate the sum of all those numbers as if they were all positive.
Oh, I see. We add up all the absolute values, so that gives us the maximum possible sum, right? Like the best case scenario.
Yeah.
But what about those negative numbers that are actually there in the matrix? We can't just pretend they're gone.
You're exactly right. That's where things get a little more tricky. We can't just ignore those negatives. And this is where we begin to think about parity, like whether we have an even or odd number of those negative numbers in the matrix.
Parity. Okay, now you've got me really curious. Why does it matter how many negative numbers we have? What does that have to do with our sign flipping strategy?
Okay, so think about it like this. Every single time we flip the signs of two numbers, right, those adjacent pairs, it's like a balancing act, you see. If we flip two negatives, boom, both positive. If we flip one positive and one negative, well, they just swap, right? But the key is we're always changing two signs at a time.
So with every flip, we're kind of keeping things balanced. The positives and negatives in the matrix, they stay in a sort of equilibrium.
Exactly. So now imagine we have an even number of those negative numbers. What we can do is pair them up strategically, flip, 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 and boom, all positives. We've reached our goal. That maximum potential sum we calculated, that's the actual sum now.
Oh, that's so smart. It's like elegant. But hold on, what if we have an odd number of negatives? Then no matter how much we pair them up, there's always going to be that one lonely negative number left over. What happens then?
Yeah, that's where we got to tweak our strategy a bit. See, in that case, we can't just get rid of all the negatives, so we focus on something else instead. We got to minimize the impact of that one negative guy that's going to be stuck with us.
Minimize the impact. Okay, so do we just find the tiniest negative number and try to leave it alone? Is that how we minimize it?
You're getting warmer. It's not quite the smallest negative number, though. We actually want to look at the smallest absolute value. Out of all the numbers in the whole matrix, find the one with the smallest absolute value. That way, if it has to stay negative, it's going to have the least impact on our overall sum, right? Because it's the smallest one.
Okay, yeah, that makes sense. But why do we have to do anything with that smallest absolute value? Why not just leave it in the sum and calculate everything?
That's a really great question. And that's where this problem gets kind of sneaky, Remember when we did that first calculation, the absolute sum, we pretended everything was positive. So what we did there was we basically let that smallest absolute value guy pretend to be positive too.
Right.
Yeah.
I see. So now we have to fix that because one number has to stay negative. We can't cheat the system. But how do we fix it? How do we adjust our calculation?
All right, so this is where it gets really interesting. We're going to take our absolute sum and we're going to subtract, wait for it, twice the smallest absolute value.
Wait, twice? Whoa, hold on a sec. That doesn't seem right. Why twice? Help me understand this.
It's a clever little trick, trust me. Okay, so think about it. We subtract it once to correct for that initial assumption, Back when we pretended everything was positive, we basically gave that smallest absolute value a free pass. So that first subtraction is like taking back that free pass.
Okay, so we're undoing that positive, so to speak.
Yeah.
But what about the second time we subtracted?
That second subtraction, that's to account for the actual value of that number. You see, it has to stay negative, so we have to subtract its value to get the real true sum. So one subtraction for the fake positive, one for the real negative.
Whoa, okay, I think I'm getting it now. That's kind of trippy, though, thinking about it like that. Undoing the positive and then adding in the negative.
It is a bit of a mind bender, yeah. But that's what we have to do, because in this case, we can't make everything positive like we want. We have to compensate.
Okay, so let me try to summarize just to make sure I got it all straight. We find the absolute sum, then we count the negative numbers. If that count is odd, boom, we find the smallest absolute value, and we subtract it twice from that initial absolute sum. And that, even though we couldn't make everything positive, that's how we get the biggest possible sum.
You got it, see? It's actually a pretty elegant solution when you break it down. Just a few simple ideas. Absolute values, checking if we have an even or odd number, and then that clever little adjustment with the subtraction. And we've solved what looks like a really, really tough problem.
It's amazing to me that one little rule, we can only flip signs in pairs next to each other. It
Yeah.
leads to such a whole strategic way of thinking.
Mm.
It's definitely not a problem where you just want to jump in and try everything.
You got that right. And that's why this kind of problem, it's like a favorite for coding interviews. It's not just about knowing how to write the code, They want to see how you think, how you analyze stuff, how you can find a good solution and not just memorize some fancy algorithm.
It's a real test. Can you solve a puzzle, not just regurgitate code?
Mm-hmm.
So speaking of interviews, what are some of the traps you see people fall into with this problem?
One big one is people rush into the coding part too fast. They don't really stop and think about the problem first. They get so focused on how to flip the signs, they forget all about those important concepts like the absolute values and that even odd thing we talked about.
So you got to slow down, right?
Yeah.
Really understand the problem, have a plan, and then you can start coding.
Exactly. Another one that trips people up is those sneaky edge cases, like what if the matrix is all zeros? Or what if there's only one negative number?
Oh, yeah, interesting. I bet those situations can really throw someone off if they're not careful. But does our solution, does it handle those weird cases okay?
Oh, yeah, it handles them like a champ. Like if you've got a matrix full of zeros, well, the absolute sum is going to be zero too, right? No need to adjust anything. Our algorithm spits out zero as the maximum sum, just like it should.
Okay, so all zeros were good. What about that one lone negative number?
That's where it gets kind of cool, because it shows how that subtract twice thing, it just works, even in those weird cases. Remember, we only subtract twice if there's an odd number of negatives, right?
Well, if there's only one negative, it's also the smallest absolute value.
Oh, yeah. So we'd subtract its value twice, which basically cancels it out, doesn't it? It's like we're giving it a little positive buddy to balance it out.
You got it. The algorithm, it just adapts. No need to change anything. It handles all those edge cases perfectly. And that's what those interviewers, they love to see that. Can you think beyond the simple cases? Can you handle the weird stuff that might break your code?
It's a real test of do you get the problem or are you just memorizing steps? Exactly. So yeah, if you're out there prepping for interviews, this maximum matrix sum, put it on your list. It's a great example, One simple rule, but it makes you think about all these cool concepts. Absolute values, that even odd thing, how to make things as efficient as possible.
It shows that the best solutions, they often come from really understanding the problem, not just writing a bunch of code.
Couldn't said it better. It's all about strategy, breaking things down.
This whole deep dive, it's been awesome. I feel like we really explored this problem inside and out.
Totally. Had a blast figuring out this matrix mystery with you.
And to everyone listening, remember, coding, it's a journey. Keep learning, keep trying new stuff. Don't be afraid to experiment, and always, always try to understand the fundamentals.
That's what AI.Code.Cast is all about, breaking down those tough problems and giving you the knowledge to ace those interviews.
And that's a wrap for today. Hope you enjoyed this deep dive into maximum matrix sum.
Happy coding, everyone. We'll see you next time.